I'm Wendy Zuckerman, and this is Science Versus, the show that pits facts against internet phenomena. Today on the show, peptides.
Here are the top 5 peptides I'd recommend to glow up before summer and flex on your ex, respectfully.
Well, then you know that peptides are everywhere right now.
Peptides. You want to know more about peptides? Look at my stash. I'm really into peptides.
Peptides are huge right now. No matter what you're struggling with, an injury that won't heal, belly fat that's pissing you off, low energy, gut issues, there is a peptide for you. People are buying this stuff off the internet, injecting themselves with it, and saying that it's life-changing.
I have never been this confident, felt this good, looked this good. You want to be on these.
For the uninitiated, there are many different peptides out there that people are injecting. But one of the biggest and most popular is called BPC-157. It's a fan favourite of Joe Rogan's. Andrew Huberman has injected it into his back. People often take it alongside another peptide in what's known as the Wolverine stack. Not so much because it makes you hairy, I wish, but because it's supposed to help heal injuries fast.
There's one peptide that seems to be good for everything, and that's BPC-157.
BPC-157 is primarily known for healing, but has a massive ability to heal your gut as well.
It's so effective. I mean, I can't even begin to tell you.
Another popular peptide out there is called MOTS-c. Folks on it are saying they're losing weight, getting energy, and they reckon it's even going to make them live longer.
There's a peptide that works like a workout you never actually did, and it's called MOTS-c.
You are leaner, you are more vascular, and your muscle definition is better.
My eyes are like open, wide. My brain is firing. I am so clear.
Guys, it's like you have unlimited energy.
But not everyone is so excited about peptides. There are the peptide heretics out there that say, you are injecting what now? This is a bad and potentially dangerous idea that could apparently even increase your risk of cancer.
Those peptides are going to kill you. Those peptides are going to kill you. What are you even doing, and where did this come from? And who told you this was a good idea?
Every time I log in, there's another influencer in my feed raving about some compound they probably heard about on a podcast 3 weeks ago.
A podcast? Who, me? Today on the show, can peptides heal you? Will they really put a peptide in your step? And the truth is that away from the internet hype, there is actually a potential revolution happening in medicine around peptides. So today on the show, we are going to find out what scientists are excited about here. We're going to look deeply at the science behind these two massive peptides, BPC-157 and MOTS-c. And I know there are a bunch of other peptides out there, so if you want to know the science on those, just let us know in the comments. And finally, we're going to look at what are the risks here. Are those peptides going to kill you? When it comes to peptides, there's a lot of...
It's so effective.
But then there's science. Science versus peptides is coming up just after the break. Welcome back. Today on the show, science versus peptides. And the first thing you have to know is what on earth peptides are. So peptides are short chains of amino acids strung together, and you can think of them as small proteins. In fact, some scientists even call them microproteins. There's thousands of peptides swimming in your body, and some do very important things, like insulin. That is a peptide. Another peptide? GLP-1s. The blockbuster weight loss drugs, they mimic an important peptide in our bodies that regulates blood sugar and helps make us feel full. So peptides are real things in science. But to know more about the current hype and what scientists are pumped about here, we need to meet this guy.
Hey there.
Hi.
My name is Hassy Cohen.
Hassy Cohen is a professor of gerontology at the University of Southern California. And he thinks we are at the cusp of a revolution when it comes to peptides. And to understand why, we need to go back to a time when perhaps you felt like you were personally victimized by Regina George. Lose My Breath by Destiny's Child is playing on your MySpace page. Maroon 5 isn't quite so irritating. And the human genome has just been decoded. That's right. It's 2004. An international team of researchers announces that after 13 years, they've found all the genes hidden in our DNA. And if you need some Biology 101, genes are instructions that tell your body to make proteins. Proteins like hemoglobin or collagen. And Hassy remembers finding out just how many genes there are in the human body.
People said there are 20,000 genes. That's it. And they do everything, which I always found to be a little bit mysterious. I didn't really think this could be true.
Hassy figured that humans are so complicated. Some 20,000 genes to make everything in your muscles, bones, brain, eyeballs, sphincters. Even at the time, one headline said this was unexpectedly low. And back then, there were clues that there's more to us than that. So when you look at our entire DNA, you roll it out like toilet paper. Those 20,000 genes are a tiny fraction of the roll.
They're 3% of the DNA. 97% of the DNA until 20 years ago, they used to refer to as junk DNA.
Ah, that's where these peptides are coming from, the so-called junk DNA.
Many of them.
That's so cool because some of the famous peptides that people know about, I'm thinking insulin, GLP-1, they're not coming from junk DNA.
Right.
But where we're discovering these sort of cool new peptides, some of those are from junk DNA.
Yes.
For years, that so-called junk DNA, and more generally, the parts of our DNA that didn't code for proteins, it was like a cipher that many scientists, including Hassy, were trying to decode. And over the years, they worked out that these mysterious chunks of DNA do loads of important stuff, including, get this, coding for not big, complicated proteins, but little baby proteins. Peptides.
Nobody expected a small protein to come out of that.
But fast forward to today, and Hassy's team has found a bunch of peptides hanging out in weird parts of our DNA. His lab likes to give them Yiddish names. Please tell me there's one called chutzpah.
So we don't have chutzpah yet, but we have mensch, we have
Mensch.
Schlep, schmooze, called mazel, like mazel tov, Hatz. We're just having fun.
Hassy's lab has found these peptides in what's called our mitochondrial DNA. Mitochondria are known as the powerhouses of our cells. They kind of look like carpet beetle larvae, but what they do is pump out fuel for our body to use for energy. And in humans, different versions of Hassy's mitochondrial peptides have been linked to lowering our risk of various diseases.
Alzheimer's, Parkinson, diabetes, obesity, cancer.
In lab and animal studies, these peptides can affect muscle growth, metabolism, oxidative stress, insulin sensitivity, and cognition. And we just keep finding more peptides. A study published in May this year found more than 3,000 peptides hiding in the mysterious chunks of our DNA. And we're not sure what many of them even do. Hassy is excited that there is this whole world of tiny proteins, actors in the human body that we didn't even know existed. And he reckons it could change the way that we understand some diseases, possibly opening the door to different kinds of medicine.
And what this microprotein revolution really embodies is the fact that instead of 20,000 genes, we probably have 1 million genes.
Wow!
Expanding the human genome by 2 orders of magnitude, that is the revolution.
Yeah, wow.
That is the transformative change.
Another researcher told me that maybe we're not going to find that many peptides. He thought it's more like 20,000, maybe 30,000. But still, that's a lot of peptides. And one of the peptides that Hassy's team has discovered completely bolted into internet fame. MOTS-c. That's right. The peptide from the start of the show that people are going bananas for, saying that it's helping them lose weight and get energy. It is one of the top 5 peptides that you should try to glow up for summer and flex on your ex. Respectfully. It's Hassy's baby.
MOTS-c is having a moment.
MOTS-c is having a big moment.
Over the last few months, I realized this is not just kind of a curiosity. Tens of thousands of people are taking MOTS-c.
Now, if you are racking your Yiddish trying to work out this one, it actually comes from a Hebrew prayer.
You say, Hamotzi lechem min haaretz.
Get it? MOTS-c. So, let's get into the science and find out if maybe you should start taking it. So when Hassy's team first discovered this little peptide, just 16 amino acids all strung together.
We had no idea what it did. And the postdoc who was working on it just started putting it on things and injecting it into mice and, let's see what happens kind of thing.
And one of the things that they did is put some mice on a high-fat diet, which would usually make them put on weight. Then they injected some MOTS-c into them.
Lo and behold, they did not gain any weight. Instead of gaining weight like they should on a high-fat diet, they didn't get any weight. And MOTS-c completely prevented 100% accumulation of fat in the liver of those mice.
Whoa!
And that was a big deal.
Fat in the liver can be dangerous. It can muck up the liver itself, but it can also lead to things like stroke. So the idea that this peptide could prevent that from happening, even when the mice were eating all these calories, that was potentially big. The team kept testing it. They gave older mice MOTS-c, and they lived longer than mice on a placebo.
You give mice MOTS-c, and you put them on a treadmill, they can run a lot longer.
Hassy's team worked out that MOTS-c might protect muscle by blocking the activity of a molecule that can break down muscle. One study found that in men, having a mutated form of MOTS-c increased their risk of type 2 diabetes and having more visceral fat. Another study found that type 2 diabetics with low MOTS-c had a higher risk of having a life-threatening cardiac event. Hassy thought, this MOTS-c, there really could be something here. So he started a company with a friend and they raised $80 million and ran a small clinical trial of MOTS-c. They got people with a high BMI and quite a bit of fat around their liver, had them come into a lab.
4 weeks, 20 people, you get injected typically in your tummy subcutaneously for 30 days.
The people were injected with either MOTS-c or a placebo. And Hassy basically wanted to know, would those getting MOTS-c lose more weight? Would they lose some of the fat around their liver? And here's what happened. When it came to weight loss and fat around the liver, the MOTS-c group did maybe a little better, but it wasn't statistically significant. They did see some more exciting stuff, though. There are these liver enzymes that tend to go up in people with fatty liver.
Those went down. Blood sugar went down, which is great.
And it was pretty safe. The biggest issue is that some people had a bit of skin irritation around the site of injection.
Which is not a complete deal breaker, but it was a little bit annoying for the people who used it.
So things were going okay, and Hassy thought that maybe this really would be a drug. In fact, he was starting to dream of larger trials with more people. But soon, a rival peptide entered the field.
Ozempic became the most successful drug in history. It was a weekly drug, and our version of MOTS-c at the time was a daily injection.
Investors told Hassy,
this is not going to make money.
And ultimately, the company folded. But since then, MOTS-c has taken on a life of its own. You can buy it online, supposedly just for research purposes, and inject yourself with it. And people are going bonkers. Just off the back of a bunch of mouse studies, one small clinical trial, and a whole lot of hype.
That created this crazy black market use of MOTS-c. And I've spoken to some people who swear that they see their athletic performance improve on MOTS-c.
Is that surreal for you? Is it so strange that
It is surreal. It is surreal.
And like I mentioned, now people are saying that they're losing fat and building muscle and amping up their energy on MOTS-c. And Hassy says, if you look at his mouse studies, maybe you could make a case for some of these claims. I mean, after all, the mice did run longer on a treadmill. But up against the hype, the research cupboard is pretty bare. After the break, we go further down the peptide rabbit hole as we dive into the science on BPC-157. Plus, could peptides really give you cancer? Coming up. Welcome back. Now let's get into one of the most popular peptides on the market, BPC-157. This is the so-called Wolverine peptide that people say can help you recover from injuries fast. So where does it come from? And should you try it? BPC-157 stands for Body Protective Compound 157. So you know immediately that it was not discovered by Hassy's team. It was isolated from gastric juice in the early 1990s by a Croatian lab. And what's curious is that humans don't actually make BPC-157. You can't find it in our DNA. So the going theory is that maybe a gut bug makes it? We don't know. But the big question is, can it heal you? For this, I called up Keith Baar, a professor of molecular exercise physiology at University of California, Davis. And he told me that recently...
So I started getting a lot of emails from people asking me, I inject BPC-157 into my tendons and they're feeling better. This is a magical thing. And I'm like, oh, that's really cool. So let's go test it.
Yeah. He wanted to see if BPC-157 can really heal tendons and ligaments, which can be very difficult injuries to treat. So it would be great if all you needed was one cheeky injection and off you go. And here's how Keith tested it. His first step is basically building a little tendon in a dish.
We take cells from people who basically rupture their Achilles. They come to our medical center to get their Achilles tendon repaired. And what we do is we take the little broken piece.
Keith's team takes the roughed up cells of the human tendon, embeds them in a gel, puts it all on a tiny bone-like scaffolding, and then yada, 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 the cells will start to replicate.
They make more cells. And so from that one ACL, that one ruptured ACL, I can make about 1,000 little engineered human ligaments.
Wow, that's so cool.
The model will grow to about the size of a toothpick, and then he's ready to test it. So the team exposes the tendon to, say, different peptides and basically sees what happens. And he told me that often it's pretty obvious if it's doing something.
If you wiggle it, normally you'll see it move a little bit. If it's stronger, it'll stay nice and stiff. If it's really weak, it'll flop around. So you can see that these drugs or these treatments are really either having an effect on the tissue or they're not.
And they've seen this with another peptide called insulin-like growth factor 1. Some people, in particular bodybuilders, use IGF-1 to get stronger. And in high doses, it's not safe. It can increase your risk of heart disease and cancer. But it's been studied for a long time, and it can help you build a bit of muscle and make you bigger. In fact, not just you.
So IGF-1, that's the difference between, say, a Great Dane and a Chihuahua.
Wait, so if you gave a Chihuahua insulin growth factor 1 at a critical point in development.
When it's very, very young and in developing still, it will get bigger and it will become a big Chihuahua. Yeah.
Okay, but away from the Chihuahua, what happened when Keith put these peptides on his lab-grown tendons?
And so when we treat with IGF-1, they get stronger. But when we did the exact same thing with BPC-157, it had absolutely no effect.
No effect.
It wasn't better, but it wasn't worse.
Keith's team tested BPC-157 a different way, bathing some human cells in it to see if they replicated faster. And again, it didn't really do anything. Now, this doesn't totally put the kibosh on BPC-157. Keith has just started studying this. He hasn't even published the data yet. He wants to keep running tests. And he says that just because BPC-157 might not do anything to his tendon in a dish,
doesn't mean that it doesn't do something when you put it into a body.
So, for example, other researchers have found evidence in rats and basically petri dish studies that BPC-157 might promote something called angiogenesis.
Or the production or the making of new blood vessels, supposed to increase the ability to get blood flow to whatever tissue that you're trying to regenerate.
And Keith says you wouldn't see new blood vessels popping up on what's basically a disembodied tendon in a dish. So to find out if this peptide really does increase angiogenesis and more broadly helps you heal from injuries, we really need to test it in a human body, right? Not just human flesh. So what studies do we have here? Let me tell you. So in 2015, a placebo-controlled safety trial for BPC-157 was registered on the US government's website for clinical trials. But the results were never published. Another study from 20 years ago of 46 people with ulcerative colitis either got a BPC-157 enema or a placebo each day for 2 weeks. And it looked like maybe the BPC-157 group did better overall. But the thing is, most of the findings weren't significant. And then there's a doctor who, by the way, wrote a book called The Fountain of Youth with Peptides. And he has a clinic in Florida where he injects people with peptides. And he gathered up 12 of his patients who he'd injected with BPC-157 because they had knee pain. And asked them basically, do you remember how bad your pain was? Is it better now? 9 out of the 12, so 75%, said that 3 months to a year later, yeah, the pain was better. Now, we have no idea if the peptide was the thing that improved their knees or the passing of time, which, you know, is supposed to heal all wounds. Or perhaps it was the placebo effect. I talked about this with Dr. Dhruv Khullar, a physician and health policy researcher at Weill Cornell Medicine in New York. And he told me that the placebo effect can be huge, particularly when it comes to knee pain.
We know placebo effects are very powerful. People who have a fake knee surgery, they have better outcomes.
Yeah, there are literally studies where doctors give someone an anesthetic, slice them open, basically stare at the ceiling for a bit, and then sew them back up. And those patients felt better to the same degree as if they'd gotten real surgery.
There are studies that suggest that, the more expensive you think a drug is, even if it's a placebo, the more effective it seems to be for you. And that's true for things like Parkinson's, which you wouldn't expect. In this case, you're going through the trouble of ordering something online. There's a bunch of syringes. It's kind of scary. You inject yourself. It's expensive. It's painful. You really want this to work.
So if all we've got are some uninspiring studies in people, why are folks online going through all this trouble for BPC-157? Where are all these exciting claims coming from that it'll heal your tendons and ligaments, that you'll become Wolverine? Well, BPC-157 has been used by folks in certain online spaces for a while now. So there is a lot of lived experience or anecdote, whatever you want to call it. But if you're looking for science for all those claims about BPC-157, what we have are studies in rats. And the vast majority of those studies actually come from one particular lab. It's the lab that first discovered the peptide in Croatia. It's the same lab that's linked to that study in people, the clinical trial from 2015, that never published those results. But for 3 decades, what this lab has published are scores of studies where they'll get a rat, cut its quadricep or ligament, slice its cornea, damage its nerve, you get the picture. And then they give one group of rats a placebo while the other gets BPC-157. And over and over and over again, the team finds that the rats injected with BPC-157 do better. I called up the professor that heads up that lab, but he wouldn't go on the record to talk. And once I started asking, why didn't he publish that clinical trial from 2015? He ghosted me completely.
Korisnik trenutno nije u mogućnosti prihvatiti poziv. Molimo, pokušajte ponovno kasnije.
So that's BPC-157. And like I mentioned, there are other peptides out there that are supposed to help you hulk up and recover faster. But a review paper looking into some of the most popular ones basically concluded there's pretty much no evidence in humans for this. I spoke to one of the authors of that paper, Dr. Cory Mayfield, a resident at Keck School of Medicine, USC.
It was more shocking on that front than to learn that how little research there had actually been.
Going in, what did you think you were going to find?
We had thought there would probably be more, at least evidence supporting the use of these. I don't think there's really any other therapy that we see that has less evidence that's more used.
So here's where we're at. Online, you are going to read and see these amazing stories of people juicing up with peptides and feeling so great and healing so quickly and popping with muscles. But if you are looking for scientific evidence that peptides are doing that magic and not the placebo or something else, you are going to be bitterly disappointed, as I kind of was. But this takes us to the last question of the episode. What are the risks? If you've got a knee injury that just won't heal, or you want to build extra muscle fast, and you want to give this stuff a go, are there any downsides? Well, if you try this, you will be injecting yourself. So you need to be careful because you could get a nasty infection. And there is the odd case report of bodybuilders using unclean needles to inject steroids and then getting infected with hepatitis C or HIV. And on Reddit, you will see people injecting themselves with peptides and then some body parts swelling up like mad and needing antibiotics. Also, if you're giving yourself repeated injections, you need to worry about lipohypertrophy, which is a buildup of fatty, rubbery lumps under the skin. Away from the needles, another issue is, how do you know what's in the vial? Right now, in the US, you can't buy a lot of these peptides at a pharmacy. You get them online, right? And Dr. Dhruv Khullar, the physician at Weill Cornell Medicine in New York, recently bought some peptides to find out exactly what was in them. It was for an article that he wrote for The New Yorker. Oddly, just as an aside, on one of the websites, they gave him a little bonus.
And when I was checking out, they just added 30 capsules of this synthetic hormone called demoxytocin for no reason, which doctors usually use for inducing labor or treating postpartum bleeding.
What?
And just like, hey, there's some other drugs you might like, I guess.
No matter, within a week, the peptides started arriving.
What did it look like when it arrived?
Oh, it's usually just a white powder, It looks maybe like some flour or cocaine.
Okay.
Depending on what you're most familiar with.
Yeah. Dhruv, I didn't know you'd make that joke. I was ready to make it, but you got in there out in front of me.
All right.
He took these peptides into a lab that tested what was inside. And the results found that one of the vials had the right peptide at the right dose. Another vial contained endotoxins, which are bits of bacteria, possibly from contaminated water in the manufacturing process. Another vial had less than half the advertised dose. And
I got one vial that had lead in it. I prefer my medications without lead.
yes, lead. And then people would be injecting it into themselves. Not great. Now, this is, of course, just Dhruv's experience. Maybe he got unlucky. We don't have studies analysing what's contained in the peptides that people are buying online. Researchers are on the case, though. But what we do have are studies on a similar illicit market, anabolic steroids. One Australian study of more than 100 samples found that 22%, so 1 in 5, were mislabeled. And they could also be contaminated with heavy metals from lead to arsenic. I asked Dhruv what the lab he tested his peptides at was seeing.
broadly, what did they tell you about how many of the peptide samples that they test have issues with them?
They estimated somewhere between 10 and 20% of the samples they receive have significant issues, whether of dosing or purity. When you're ordering these unapproved drugs online, you don't really know what you're getting.
It's just like a box of chocolates.
Exactly.
Basically, in this unregulated market, these peptides are coming from factories where the quality control is not up to snuff. Now, this may change in the US soon. The FDA is meeting in July to talk about letting compounding US pharmacies make a handful of peptides, including MOTS-c and BPC-157, and then sell them directly to the public. Of course, that's not going to make them effective, just less likely to have lead in them. But there is one more risk that we need to talk about, and that is around cancer. Like I mentioned, some peptides are supposed to work by encouraging blood vessels to grow. And this, in theory, could increase your risk of cancer because giving cancer cells a blood supply gives them the nutrients to survive and spread. I talked about this with Dr. Cory Mayfield.
I know anyone who would have had a scan for some weird thing in their body, one of the tests for is that weird thing cancerous is are there blood vessels around it or not?
Correct. Yeah, that's the main thing we look for is, is it getting blood? Is it new blood? Is it pulling in its own blood supply? And that's what we worry about.
We don't know for sure if this is a risk or even if some of these peptides increase angiogenesis in the first place. But the thing is that if peptides actually do what people are saying they can, if they are modulating your body in all of these different and exciting ways, they probably will have some side effects. I mean, think about the peptides that we have good research on. So GLP-1s, for example, they work really well. But if you're losing a ton of weight, you need to worry about muscle loss. They can also cause nausea and diarrhea and rarely gut paralysis. IGF-1, like I mentioned, can increase your risk of cancer and heart disease. None of the doctors and researchers that you heard from in this episode, Dhruv, Cory, Keith, and Hassy, inject themselves with peptides. I talked to Hassy about why he's not injecting MOTS-c.
And let me say that I am coming of age, and I'm very worried about my muscle loss, my sarcopenia. I'm worried about this. If MOTS-c was approved, I would take it right now. Will I ever take it? I don't know. At the moment, I'm not taking it.
Why not?
Because I don't trust the stuff that people are taking out there. I don't know where they're getting it, how it's mixed, how it's prepared.
But you're one of the few people out there that could actually get MOTS-c and know you're getting MOTS-c, but you still don't take it.
It's true.
Why not?
Because I'm an old-fashioned traditional guy. And, when you're raised with values as a physician scientist, all the supplement universe is something that you really disrespect. And the majority of supplements is a multi-billion-dollar business. Almost all of them don't work. And I've always said to myself, why are people doing it? They don't know. There's no evidence. So I come from a place of a traditional, old-fashioned physician scientist who believes there's a right way to do it and a wrong way to do it.
And while I get the impulse to want to be your best self, and I know how frustrating it is when injuries take a long time to heal, and I also think that the potential peptide revolution happening in science land, it could be super cool. But at the same time, injecting yourself with stuff that some influencer, or worse, podcaster, is selling you online, as Hassy would say, it's the wrong way to do it. I guess I'm old-fashioned like that too. That's Science Versus. This episode has 73 citations in it, and if you want to see them in all of their glory, then you can look at the show notes and link to our transcript. It is a fully cited transcript, so if I said anything and you think, wait a second, go check it out for yourself. This This episode was produced by me, Wendy Zuckerman, with help from Rose Rimler, Katie Foster Keys, Meryl Horn, and Michelle Dang. We're edited by Blythe Terrell, fact-checking by Diane Kelly. Video editing and sound mix by Bobby Lord. Music written by Bumi Hidaka, Peter Leonard, Emma Munger, and Bobby Lord. Thanks to the researchers that I spoke to for this episode, including Dr. Dana Liss, Dr. Puya Faridi, and Dr. Timothy Pietkowski, as well as the Australian Science Media Centre. Thanks for all the papers. A big thanks to Joseph Lavelle-Wilson and the Zuckerman family. Science Versus is a Spotify Studios original. We are also now on YouTube. Yeah, you can find us at Science VS Podcast. Come and say hello. We have no idea how YouTube works. We're podcasters, OG podcasters. Still, you can listen to us for free on Spotify, YouTube, wherever you get your podcasts. Follow us, like and subscribe. I don't know. I'm Wendy Zuckerman. Back to you next time.